Okay, sorry about that. My video got cut off for some reason. So when I went to my chart, I was using alpha 0.5 and N was 11 because this was data from 11 students. And what I found was a critical value of 0.602. So I'm going to have positive 0.602 and negative 0.602. So these are my two reject regions. What we found up here was that our R value was 0.51. So if you imagine that the middle is 0, our R value of 0.51 is right here. So based on our sample size that we had and our confidence level or our alpha value, this is not enough to put us in that reject region. Now, another thing that we're going to compare, going back to my calculator here, I've got my p-value of 0.11. So we have p-value equals 0.11. So our p-value is greater than alpha, which was 0.05. So both of these things tell us that we fail to reject the null. Now, it says give the regression equation. So what I would do here, and this is not so important in a case where you fail to reject, but I still want to show you. My regression equation would be y hat equals negative 76.52 plus 3.49x. So we're failing to reject y hat, or h sub o. Sorry about that. Okay, so now what we want to do is we want to run a residual analysis. So remember, this is in our computer, our calculator, and our formula for a residual is equal to y minus y hat. So that's why we still need this formula so that we can calculate our residuals correctly. So I'm going to go just on a blank calculator screen. The first thing that I need to do is calculate the predicted value for all of my scores. So I'm going to do negative 76.52 plus 3.49, but instead of times x, I want to do times L1 because L1 is where my x's are. Then I want to store this in L3. So this gives me all of the predicted final exam scores. Now what I want to do is calculate my residuals, which is my y values, which are in L2, minus my predicted values, which are in L3, store that in L4. So now I'm going to go to stat edit. So there's all my predicted scores, and here are all of my residuals. Okay, so part of your residual analysis, the two main things that you want to give are the mean of the residuals, and then you want to look at a scatter plot of the residuals. So the first thing I'm going to do is my mean. So I'm going to go to stat calc, and I want to calculate that for L4. So I have a mean of 0.075. So pretty close to 0. But if you remember the example the other day in the residual analysis notes, it was like 0.00 something. It was really, really small. The next thing that I want to do is make a scatter plot. So X should be L1, Y should be L4. I want to clear out my equation, zoom stat. So not really a super noticeable pattern or anything here. So nothing really stands out to me as far as the scatter plot goes. Okay, so now what we want to do is interpret all the findings. So what I'm going to say here is, hang on guys. Okay, so based on R and R critical, as well as p-value, we fail to reject. The mean is not equal to 0, which supports this decision. So I understand that it's very close. And like I said, even though we really didn't have a distinguishable pattern in our scatter plot, we're still going on that critical value p-value. That's going to be the one that majorly decides. So because of this, the model is not a good predictor of final exam scores. So we could still use the model to make predictions, but if you were doing actual real scientific research that you were going to publish, yes, I can still plug values into an equation, but should I take them as truth based on our findings? No, we should not. So I'll go ahead and do this just for the extra practice. So the formula is y hat equals negative 76.52 plus 3.49x, where again, x is our third exam score. So it says predict the score for a final exam given a score of 68 on the third exam. So what I would do there, I'm telling you what, guys, these kids are nuts today. I'm going to take and I'm going to plug in my score of 68. So if I do negative 76.52 plus 3.49 times 68, then I am predicting that they will get 160.8 out of 200 points. I can just as easily change that to 78 and 195.7. Now, what if we asked a question about predicting, what if they scored a 12 on exam 3? Something crazy like that. So one of the things that I kind of mentioned earlier is this model is not going to be entirely accurate. And really, in predicting scores, it's really only accurate within the scope of the data that we have collected. And in this case, because we failed to reject, it's really not accurate at all. But if you were publishing research, you would not want to make predictions much further from the realm of the data that you have collected here. And that's called extrapolation. You have to assume with extrapolation that this pattern that you're seeing right here continues forever in both directions. And if you don't have data to support that, you can't be positive that it does. So you have to be really careful with making predictions outside of the realm of scores that you have. So we really wouldn't want to make any predictions outside of 65 to 75. So, we could maybe go a little bit, maybe 60 to 80, but you don't want to go much farther than the scope of the data that you have collected. Okay. So that's just kind of a quick example of how to set up the test. It's really, I think, pretty simple in comparison to some of the other tests that we've done. So I'm going to post another example for you guys to try, and then I'll post the answer key to that at some later point also.